This is a physics question in a unit about solids and liquids, and it's an Onramps physics. Onramps in high school comes from university, and different people will get the question problem with different numbers, but I'm just using this one with these numbers. And I've drawn these little triangles here to remind how things relate one to another. Mass is volume times density. Volume is area times height, but in this case, it's called L there, so I put L. So we're going to need those in a little while. It says a heavy liquid with a density of 11 grams per cubic centimeter is poured into a U-tube, not a video, but this tube that's shaped like a U. The left-hand arm of the tube has a cross-section area of 15.1. The right-hand arm has a cross-sectional area of 5.73 squared centimeters. A quantity of 104 grams of a light liquid with a density of 1.7 grams per cubic centimeter is then poured into the right-hand arm as shown. So it's got it all there. Determine the height of the light liquid in the column in the right arm of the U-tube as shown in the second figure above. So that's where these things come in. I need, it's asking me for that length, that height there. And height, or that L, it should be H, but I put L like they did. L equals the volume of the liquid divided by the area of the liquid. So, you can memorize these two triangles. Do I know the volume of that liquid? I certainly do not know the volume of the liquid because I need the L to find the volume and I don't know the L. But I have another formula that I can use for volume. Volume equals a mass divided by density. So L equals the mass divided by density divided by area. Well, if I multiply, this is area over 1, I multiply, or I put in the numerator by flipping it, 1 over area. And so L equals mass over density times area. And this is, by the way, this is the density of the light liquid, because that's what's going on. So now I can find the L. The length equals, let's see, the mass of the light liquid, 104 grams, divided by the density of the light liquid, 1.7, times the area that it's occupying, 5.73. And I can write the units in, but I'm just going to make sure the units are consistent. It's grams, 104 grams, squared centimeters, grams per cubic centimeters. All my units are consistent. So that's the exact value. It equals to some approximate value. Let me go to Desmos here and find the approximate value. I just had Desmos. Okay, so it's 104 divided by 1.77 times 5.73. This is the exact value. Approximately 10.6 centimeters. All right, so there's that one. Approximately 10.6 centimeters is that length. Now, in the second part, question 8, I have to use that L. You can use 10.6 for L, or use more digits, 10.676. But I'm going to use 104 divided by 1.7 times 5.73. I don't want to round I only want to round at the end. Here's an example of why. Let's say I want to round this to the nearest whole number. 5.4 plus 5.4. 5.4 plus 5.4 equals 10.8. And now if I round that to the nearest whole number, it's 11. But what if I round it at this stage? I round it in the middle of the calculation. 5.4 round to the nearest whole number is 5. 5.4 rounded to the nearest whole number is 5. 5 plus 5 is 10. So you can see it creates inaccuracy. So I'm going to use the exact value for L, and then I am going to round the final answer, and that's for the second part. It says the density of the heavy liquid is 11 grams per centimeter, cubic centimeter. By what height, H1, does a heavy liquid rise? Well, here's a situation. The liquids are like that. And you can see, and look at on this right side here. So the heavy liquid loses this much height. So what the heavy liquid loses there is H2. And this is area 2. I'll call that area 2. You'll see why in a moment. And the heavy liquid gains H1. And I'll call this area 1. And there's something called conservation of volume. None of this heavy liquid pours out of this U-tube. So the volume must be conserved. In other words, H1 times A1, which is the volume on the left that it goes up, has to equal to H2 times A2. The volume that it goes down on the right, those two volumes have to be equal. Otherwise, there's no conservation of volume. What happened? It got pressed down, and then it turned into a black hole and sucked itself in and went into oblivion? No, the volume has to be conserved. So this is conservation of volume. And I have to solve for H1, so I'm going to use this to put H2 in terms of H1. So if H2 ends up in any of my equations, I can put it in terms of H1 and then solve for H1. So H2 equals, I'm just going to divide both sides by A1, height 1 times A1 divided by A2, that's H2. So now I can fix it. Now, what's going on in part 2? It says, how far does what is the H1? Does a heavy liquid rise? Well, this is putting pressure, and this part is putting pressure. And the pressure on the left, once everything happens, the pressures are going to go into equilibrium. It's not moving anymore. Eventually it's going to settle down, and it's going to be at whatever height it is. So the pressure that's coming from the heavy liquid has to equal the pressure of the light liquid. Or, this is really the pressure of the left side, and this is the pressure on the right side. They have to equal eventually, and it's going to stop moving. It's not always going to keep oscillating. Eventually it's going to come into equilibrium so that you can measure all these things. Well, what is pressure? Pressure equals density times the force of gravity times the height. So let's look at the heavy. I will look at the heavy liquid. It's going to be the density of the heavy liquid times, not force of gravity, acceleration due to gravity, times this height of heavy liquid, which is H1 plus H2. So times H1 plus H2. And that's going to have to equal the density of the light liquid times its height. That's all being pulled down by the force of gravity according to gravitational acceleration, and that's going to be G. Well, first thing I notice, the G's cancel. That's good. Always trying to simplify. And now I don't want to find H2, so that's where this calculation came in. Using the conservation of volume, I will replace H2 with H1A1 over A2. So the density of the heavy liquid times H1 plus H1A1 over A2, those are those areas, equal the density of the light liquid. Oh, I forgot the height on that side. Oh my goodness, how come no one told me? Times L. L is that height. I forgot to put the L. All right, now I will factor out H1 so that I can solve for it. It would be like this. If I had x plus x over 3, and I wanted to factor x out, I could write x, and then x divided by x is 1, x divided by x is 1. So I'm going to factor out that H1. H1 times the density of the heavy liquid equals 1. H1 divided by H1 is 1. H1 divided by H1 is 1. And that just leaves plus A1 over A2. And that equals the density of the light liquid times that L. And I can't believe I forgot that one. So now H1 equals, and I'm going to do something here that I can't do on paper just to make it easy. I'm dividing both sides by all of this stuff. So I'm just, whoops, I didn't want to get that 2 up there. Oh, maybe I'm not going to be able to do it. Well, I'm just going to take that little part of the 2. And so it is actually H1 is equal to the density of the light liquid times L, the height of the light liquid. That's L. Divided by the density of the heavy liquid times its height, which is H1 plus H2, which is 1 plus A1 over A2 is left over there, and then that I will solve for H1. So now I'll put the numbers in. Density of the light liquid, 1.7. L, again, if you want to round in the middle of a calculation, put 10.6 or 10 point, whatever it was, 676. I guess it would be 10.677, whatever. I'm going to put 104 divided by 1.7 by times 5.73. So that's the exact value of L. 1.04 divided by 1.7 times 5.73. Since I'm just going to add on what I have in Desmos, I won't cancel, but this 1.7 would cancel with that 1.7, so you wouldn't have so much to enter because it's in the numerator and multiplying and then in the denominator. And then the density of the heavy liquid is, where is that thing? 11 times 1 plus A1 over A2. What is A1? 15.1 and 5.73 plus 15.1 divided by 5.73. All right, so now I'm going to put that all in. See, I already have this one. 104 divided by 1.7 times 5.73. I can just build on it in Desmos times 1.7. And then that whole thing divided by 11 times 1 plus 15.1 divided by 5.73. And that equals approximately 0.454, approximately 0.454 centimeters. You can write all the units in, but I just, instead of writing them all, I'll just check. The areas are given in squared centimeters, the densities, grams per centimeters, all the masses are given in grams. There's no conversions necessary, so it's in centimeters. So approximately 0.454 centimeters is that height, this little height that the heavy liquid rises, and the height of the light liquid is L, which again is exactly 104 divided by 1.7 times 5.73, but it's approximately 10.6 centimeters.